Welcome to Areas of Other Quadrilaterals. We've already learned about rectangles and squares and parallelograms, so we're going to learn the rest of them today. And there's your formulas. We have a trapezoid is 1/2 times the height times base 1 plus base 2. So when we have a trapezoid, remember, the parallel sides are your bases. Your height, as always, is going to be marked with a right angle. So again, if you see when I draw the height, you might see a right triangle, so you'll probably be using Pythagorean theorem again to find your height. When we have a rhombus, you have diagonal 1 times diagonal 2. Please remember those D's stand for diagonals. So we have a rhombus here, diagonal 1 and diagonal 2. Same formula for a kite. So there's your kite, diagonal 1 times diagonal 2. If you remember, in the middle of a rhombus or a kite, your diagonals are perpendicular. So again, we are looking at right triangles again. Our first example here, we have the free throw lane on an international basketball court is shaped like a trapezoid. Find the area of the free throw lane. So we're looking at a trapezoid. We're going to write down our formula. Area equals 1/2 times the height times base 1 plus base 2. So let's see if we have all the information we need. 1/2, our height, remember, is marked by a right angle. So our height here would be 5.8. Base 1 plus base 2, it doesn't matter what you use as base 1 or base 2. I'm just going to use 3.6 as my base 1. Plus base 2, I'm going to use as 6. And then from there, use your order of operations. Of course, we have to do what is inside the parentheses, so we do have to add together the 3.6 and the 6. So it'll be 1/2 times 5.8 times 3.6 plus 6 would be 9.6. And I'm going to put it in my calculator and multiply 1/2 times 5.8 times 9.6, and that gives me 27.84. Please remember this is area, and so I will need a unit of meters squared. And that's my final answer there. Let's look at example 2. We want to find the area of this shape. So first thing you need to notice is all the sides are marked congruent, so that does make this a rhombus. When we're doing a rhombus, its area equals 1/2 times diagonal 1 times diagonal 2. So if we look here, well, that 50 is the length of a side, and the 30 is going to be the length from this tip to the center. But as I had already mentioned, our diagonals are perpendicular, and I only know the length of one diagonal, so I'm going to have to find the length of the other diagonal. So we will have to use Pythagorean theorem. Here's my right angle. It's pointing directly towards the 50. So that's going to be my C. And then my 30 would be my A. And then the one I don't know would be my B. So we start with 30 squared plus B squared equals 50 squared. 30 squared would be, I believe, 900. Okay, plus B squared equals 50 squared would be 2,500. Remember, we have to subtract 900 from both sides. So B squared equals 1,600. And then I have to square root both of that. So my B is going to be 40, which means the length of this side is 40. But please remember that was only from the corner to the center. So if we remember anything about diagonals in any of our parallelograms, whatever the length was here is the length over here. So this one is 30. And if this length is 40, that means the length over here is 40. So when I do my area, diagonal 1, I have to do 30 plus 30, which would be a total of 60. For my diagonal, and here 40 plus 40 would be a total of 80 for my area there. So I'm going to take 1/2 times 60 times 80